And something else that's kind of cool, just to go back to the absolute value one, is if you do want to, you could actually at the beginning subtract 8 from both sides, get the absolute value of 3x minus 2 and minus 4 equals 0. And we could graph that and look for the x-intercepts, if that's like a method that you've been liking or enjoying. If you go to your y equals, the way to get the absolute value is you click math, num, ABS stands for absolute value. We can type in 3x minus 2, subtract 4, and the intercepts are the solutions. And we can see right here, this is x equals 2, and then a negative, x equals negative something. So without even doing anything, we can see there's 2 solutions. One of them is positive 2, and that narrows it down to b. So this is a pretty fast method. Just make sure that if you're graphing, you always set it equal to 0 first, so that you can find the x-intercepts. All right, let's go on to the next one then. So again, one option for this would be similar to that, like solve by graphing. If you want to graph it, you have to set it equal to 0. So we could go x plus 3 minus 2x equals 0, and look for the x-intercepts. So let's try that first, and then I'll show you how to actually solve it for some solutions. So square root of x plus 3. Make sure you arrow out to get that subtract 2x. And then if I graph it, it looks like there's one solution that works at 1. Looks like there's one solution that works at 1. So let's just check. All right. The opposite operation of the square root, like if I have the square root of x squared, those two things cancel out because they're opposite operations. So I'm going to square both sides, and I'm going to square the whole of both sides. When you do that, it gets rid of the square root. So I have x plus 3 equals 2 squared is 4, and x squared. Now we have a quadratic. So I'm going to set it equal to 0 by subtracting the x over and subtracting the 3 over. And that's something that I can now use a lot of different strategies for. I can graph it, right? I could use the quadratic formula. I could try to factor. This one does look factorable. Negative 12 would be negative 4 and positive 3, or factor that. Oh, but there's a 4 in front. Right. So x equals 1. You can see here, this is probably negative 3/4. I'm just going to say, judging by the multiple choice, x equals negative 3/4. We can check it if we want. Originally, we only found x equals 1, so I wonder if the negative 3/4 doesn't work in there. Yeah, it doesn't. Oh, cool. Okay, so x equals 1 is the correct answer, because if you plug in to like check your work for extraneous solutions, the 1 into the equation, you get the square root of 4 equals 2. That one works. If you check the negative 3/4 in here, square root of negative 3/4 plus 3 equals 2 times negative 3/4. A square root of something will never equal a negative value because it's imaginary, right? So like, it's negative underneath the square root's imaginary, but like the square root of something will never be a negative number. So that means that it doesn't work. And that's why only the 1 is the solution. So however you solve it, make sure you check your work with two solutions, because sometimes one of them is extraneous, it's called. That means it does not work in the original. One way to bypass that would be just to graph it at the beginning and look for your x-intercepts. So that's kind of a cool, fun one. Here's another one. Let's try two methods, all right? First method, let's try graphing and see how that works. In my y equals, I'm gonna subtract them to get them set equal to 0. So if I want to graph, it's gonna be x plus 2, subtract x plus 4. That's how I would get it set to 0. So if I want to check on the graph. Square root of x plus 2 minus x plus 4. Yeah, that's only got one also. Betting that's 7 over there. So I'll just say 7. Let's check it. All right. If you want, I mean, if it's time test, I would just move on from there. But the opposite operation is to square it. We do want to square both sides. So you get x plus 2 equals x minus 4 squared. Now this is something that we're going to have to distribute. All right. And if we have a binomial squared, all right, that's the same as x minus 4 times x minus 4. Squared means it times itself. So I'm going to distribute this in and combine like terms. That equals x plus 2. To solve a quadratic, you need to set it equal to 0. So I'm going to subtract over the x and the 2. This one actually looks faster to me by factoring because there's a 1x squared in the front, and I can see that 2 times 7 is negative 2 times negative 7 is 14, and negative 7 plus negative 2 is negative 9. So when I set these to 0, I get x equals 7 and x equals 2. Now I'm curious because I got just 7 on my original graph, so let's see why. If I check those in the original equation back up there, I'm going to plug in 7 first, 7 plus 2, and see if the left side equals the right side. 9, square root of 9 is 3. That one works. So let's check the 2 now to see if it works, if the left side equals the right side. Square root of 2 plus 2 equals 2 minus 4. Square root of 4 equals negative 2. Nope. So that is an extraneous solution, it means, because 2 does not equal negative 2. Those are different values, different numbers, and that's why the negative 2 does not work. So just 7. Happy solving!